The emergence of Web 3.0, decentralizing the digital world. The Internet has undergone profound transformations since its inception, each evolution marking a significant shift in how we interact with information, communication, and commerce. These phases, commonly referred to as Web 1.0, Web 2.0, and now Web 3.0, represent the growth of the web from a static information repository to an interactive platform and, more recently, toward a decentralized network built on blockchain technologies. Web 3.0, often touted as the next generation of the Internet, promises to redefine the web's architecture by decentralizing power structures, providing greater user autonomy, enhancing privacy, and enabling new forms of digital assets. This essay explores the origins, key technologies, challenges, and potential impact of Web 3.0. Web evolution, from Web 1.0 to Web 3.0. To understand the implications of Web 3.0, it's essential to examine its predecessors and how the Internet has evolved. Web 1.0, the static web, the early days of the Internet, from the 1990s through the early 2000s, are classified as Web 1.0. In this phase, websites were largely static, meaning they primarily displayed read-only content. Users could consume information but had limited ability to interact with it. Websites during this era were simple and functioned much like online brochures, offering information without much interactivity. Web 2.0, the social web around the mid-2000s, the Internet evolved into what we know today as Web 2.0. This era brought about dynamic content and interactivity. Platforms such as Facebook, YouTube, and Twitter allowed users to create, share, and engage with content. Web 2.0 transformed the web from a static repository of information into a participatory, user-driven platform. However, the rise of centralized platforms gave corporations immense control over user data, creating privacy concerns and monopolistic power structures. Web 3.0, the decentralized web. Web 3.0 represents a fundamental shift from the centralized control of Web 2.0 to a decentralized, user-centric web. Unlike its predecessors, Web 3.0 leverages emerging technologies like blockchain, decentralized protocols, and artificial intelligence to redistribute control from large entities to individual users, while promoting transparency, privacy, and trustless interactions. The core pillars of Web 3.0. Web 3.0 is built on several core principles and technologies that differentiate it from the previous eras of the web. 1. Decentralization. At the heart of Web 3.0 is decentralization. Unlike Web 2.0, where data and content are stored in centralized servers owned by companies like Google, Facebook, or Amazon, Web 3.0 envisions a network where data is distributed across multiple nodes or servers. This is often facilitated by blockchain technology, which allows information to be stored on a public ledger, transparent and accessible to all, yet secure through cryptographic methods. Blockchain eliminates the need for intermediaries, centralized platforms or third-party institutions, in online transactions and information exchange. Instead, decentralized apps, dApps, allow users to engage with each other directly on peer-to-peer networks, increasing user control over their data and reducing the risk of censorship or corporate influence. 2. Blockchain technology. Blockchain is the foundational technology driving Web 3.0. It offers a transparent and immutable ledger of transactions and data storage that is distributed across a network. Key features of blockchain that are relevant to Web 3.0 include trustlessness. Interactions in Web 3.0 are trustless, meaning users do not have to rely on intermediaries or centralized authorities to verify transactions or interactions. Blockchain consensus mechanisms, such as proof of work or proof of stake, ensure the integrity of transactions. Transparency and security. Because all transactions on a blockchain are recorded publicly and cryptographically secured, the system becomes both transparent and highly secure, making tampering nearly impossible. Smart contracts. Smart contracts are self-executing contracts with the terms of the agreement directly written into code. These contracts run on blockchain networks and automatically enforce agreements without the need for intermediaries, making processes like payments, legal agreements, and exchanges more efficient and secure. 3. Tokenization and digital ownership. Web 3.0 introduces new concepts of digital ownership and value exchange through tokenization. In Web 2.0, data is stored on corporate servers, and users have little control over how their personal information is used. In Web 3.0, tokenization allows digital assets, including data, to be owned by individuals rather than companies. These assets are represented by tokens that can be traded, sold, or held, enabling the creation of decentralized economies. Non-fungible tokens, NFTs, a form of digital asset, have become one of the most popular manifestations of Web 3.0. NFTs allow users to prove ownership of unique digital goods, from artwork and music to virtual real estate in metaverses. This decentralization of ownership is a cornerstone of Web 3.0, empowering users to reclaim control over their digital property. 4. Interoperability and open standards. One of the key features of Web 3.0 is interoperability, which means that different platforms, applications, and systems can seamlessly interact with each other. Web 3.0 is built on open protocols, allowing developers to create decentralized applications, dApps, that work across multiple blockchain networks without needing a centralized authority to mediate. This openness fosters innovation, enabling the creation of a more inclusive and connected internet. Interoperability allows for the seamless transfer of assets and information between decentralized platforms, making the web more fluid and reducing the need for data silos controlled by monopolistic companies. 5. Privacy and data sovereignty. In Web 3.0, users are in control of their data, a major departure from Web 2.0, where user information is often monetized by corporations without their consent. Decentralized identifiers, DIDs, and self-sovereign identity systems give users the ability to manage and control access to their personal data. This ensures that users can decide who has access to their data and how it is used. Web 3.0 also incorporates zero-knowledge proofs and privacy-enhancing technologies that allow users to verify their identity or complete transactions without revealing sensitive information. This is particularly important in protecting individuals' privacy and preventing data breaches, which have become all too common in the centralized web. 6. Artificial intelligence and automation. Web 3.0 is set to leverage advancements in artificial intelligence, AI, to create smarter, more personalized experiences for users. AI-driven systems can analyze vast amounts of data in a decentralized manner, helping users navigate complex information landscapes, automate tasks, and offer intelligent solutions without the need for centralized data centers. For example, AI combined with blockchain can facilitate decentralized finance, DeFi, applications, where algorithms automatically manage investments, loans, and trading with minimal human intervention. AI can also enhance search functionality in Web 3.0, improving the user experience by offering more accurate and context-aware results. Applications of Web 3.0. The decentralized nature of Web 3.0 opens up a world of possibilities across various industries. Finance, decentralized finance, DeFi, is perhaps one of the most prominent applications of Web 3.0. DeFi protocols allow users to access financial services, such as loans, insurance, and trading, without traditional banks or financial intermediaries. Smart contracts automate these services, reducing costs and increasing accessibility for users worldwide. Content creation and digital ownership. Through blockchain and NFTs, content creators are gaining more control over their work. Artists, musicians, and writers can sell their creations directly to their audiences without relying on platforms that take large cuts. NFT marketplaces and decentralized content platforms offer creators more autonomy and ownership of their intellectual property. Supply chain management. Blockchain technology is transforming supply chain management by providing transparent and immutable records of products' origins, movements, and ownership. This can reduce fraud, increase efficiency, and ensure that consumers are buying ethically sourced goods. Healthcare. Web 3.0's decentralization and privacy features offer solutions to many of the challenges facing healthcare, such as patient data privacy and interoperability between different healthcare systems. Patients can store and control access to their health records on the blockchain, ensuring data integrity and protecting their privacy while enabling seamless access to authorized medical professionals. Decentralized autonomous organizations, DAOs are a new form of organization enabled by blockchain technology, where decision-making is decentralized, and participants use tokens to vote on governance issues. DAOs represent a shift in how companies and organizations can be structured, with a focus on collective ownership and democratic participation. Challenges of Web 3.0. Despite its potential, Web 3.0 faces several significant challenges. Scalability. Blockchain networks often face scalability issues, with slow transaction speeds and high energy consumption. For Web 3.0 to reach mass adoption, improvements in blockchain scalability, such as Layer 2 solutions or more efficient consensus mechanisms, are necessary. User experience. Decentralized applications, dApps, can be difficult for non-technical users to navigate. Complex interfaces, the need for digital wallets, and dealing with cryptocurrencies may deter widespread adoption. To succeed, Web 3.0 must improve usability and make decentralized systems more accessible to the average user. Regulation and security. The decentralized nature of Web 3.0 makes it difficult for governments to regulate. This lack of oversight can lead to concerns about money laundering, fraud, and other illegal activities in decentralized finance and other sectors. At the same time, ensuring security on decentralized platforms is critical, as hacks and exploits in smart contracts can lead to significant financial losses. Transition from Web 2.0, moving from a centralized web to a decentralized one will be a gradual process, and many users, companies, and institutions are deeply embedded in the Web 2.0 ecosystem. Convincing major platforms and users to shift to decentralized alternatives will be a major challenge. Conclusion: the future of Web 3.0. Web 3.0 represents a bold vision for the future of the Internet, one where power is decentralized, users own and control their data, and the web becomes a trustless, transparent space. While the technologies underpinning Web 3.0, such as blockchain and AI, are still maturing, they have already begun to disrupt industries like finance, content creation, and supply chain management. However, the road to full Web 3.0 adoption will be paved with challenges, including issues of scalability, regulation, and usability. As the technology continues to evolve, it remains to be seen how society will embrace this new paradigm and what role it will play in the future of the digital world. One thing is certain: Web 3.0 has the potential to revolutionize the Internet, creating a more democratic and user-focused experience while challenging the monopolistic control that has characterized the current era of Web 2.0. If successful, it could usher in a new age of digital empowerment and transform the way we live, work, and connect in the digital age.